Okay, in this last video, I'm going to go over number 5 from the free response review for unit 4. Okay, so we're finding absolute max and min values for this function. And the way I taught you to do this is we're going to plug in the endpoints. All right, I like to do that first. You don't have to, but at some point you're going to have to. So I'm going to plug in f of 0. So that's e to the 0 power times the cosine of 0. E to the 0 power is 1. And then if you're thinking about your unit circle, the cosine of 0, right, that ordered pair is going to be 1. So that's going to be 1 times 1, which is 1. So this ordered pair is 0, 1. Let's plug in 2 pi. So plugging in 2 pi gives me e to the 2 pi power times the cosine of 2 pi. E to the 2 pi power is just e to the 2 pi. Cosine of 2 pi, that's all the way around. It's actually the same ordered pair as when you have 0 for your angle. So the cosine of 2 pi is going to be 1 as well. So that's e to the 2 pi power. So this ordered pair is 2 pi, comma, e to the 2 pi. So that's it for my endpoints. Now to find the other values I might plug in, I need to take the derivative, right? And whatever I find, figure out what makes that derivative equal to 0 or undefined, and that would give me my critical points to then see if I'm going to use those to plug into this original function. Okay, so the derivative of this, I'm going to use the power rule, the product rule. The derivative of e to the x is just e to the x times the original second function, which is cosine of x, plus the derivative of cosine is negative sine of x times the original first, which is e to the power of x. If you'd like to factor out the e to the power of x, you can, because they share it. That gives you the cosine of x minus the sine of x. Now, there's no way to make this undefined, so I'm going to set it equal to 0. There's actually no way to make e to the power of x become 0, right? E to the 0 power is going to be 1. E to the first power is e. E to negative powers, like e to the negative first power, is 1 over e. So this one will never be able to give a critical point. But if I set this one equal to 0, I can move that minus sine x over to be cosine of x equals sine of x. And now I'm thinking about what I did in trigonometry. If I just show you the unit circle here, if you guys remember the angle that was pi over 4, right? So halfway in that first quadrant, this angle was pi over 4. And the sine of pi over 4 was the square root of 2 over 2. And the cosine of pi over 4 was the square root of 2 over 2. So one of my x values that's going to make this true is pi over 4. And then if you remember, right, the idea of all students take classes in terms of the signs, SIG and S, of these different trig ratios, right? In the second quadrant, the sine of 3 pi over 4 is going to be a positive square root of 2 over 2, but the cosine of 3 pi over 4 is going to be a negative square root of 2 over 2, so it's not going to be in this quadrant. That doesn't work. All right, same with my fourth quadrant. The cosine would be of 7 pi over 4 would be positive, but the sine of 7 pi over 4 would be negative. So this is the other quadrant, tangent, because both the cosine and the sine of the angle that has a reference angle of pi over 4 would be negative. So it would work here. And that one is going to be 5 pi over 4. The way my brain does this is halfway around is pi or pi over 4. And then if you move into this quadrant by that reference angle of pi over 4, adding together, you get 5 pi over 4. So these two are my critical points. And if you notice, in terms of the original x values for the domain 0 to 2 pi, both of them are actually in that. So we're going to plug in both of these. So f of pi over 4, let's plug that in. So e to the pi over 4 times the cosine of pi over 4. Again, I don't really know the e to the pi over 4 is, so e to the pi over 4 times, and let's see, cosine of pi over 4, we said that was the square root of 2 over 2. So that's it for the first one. Let's plug in 5 pi over 4. So e to the 5 pi over 4 times the cosine of 5 pi over 4. And this one is going to have that same e raised to the 5 pi over 4, but this time the ratio is going to be negative because it would be in the third quadrant where cosine is negative, so negative square root of 2 over 2. So now I am analyzing the y values for all 4 of these points that I plugged in. I plugged in 0, got 1. I plugged in 2 pi and got e to the 2 pi power, plugged in pi over 4 and got all of this, and then plugged in 5 pi over 4 and got all of that. Now, the one that's the easiest to pick is the absolute minimum. Only one of those 4 that I just highlighted is negative, that last one. So that will be our absolute minimum. The absolute max is probably a little bit more difficult to see. All right, so the absolute maximum is end up going to be this one here, e to the 2 pi power, because that is going to be larger than e to the pi over 4 power times that square root of 2 over 2. So the absolute max is e to the 2 pi power, and the absolute min is a little simpler to see. That's going to be negative e to the 5 pi over 4 power times the square root of 2 over 2. All right, so that's how you do that. I put this on the review just because there's a lot of kind of like trig review in there, and if you're not necessarily brushed up on your trig, that would be a pretty big hurdle to clear on this question. But just a reminder, in May on the AP exam, no holding back from College Board on asking trig questions. Okay, find the intervals on which f is increasing. So the way we've done this with algebra has been to take the derivative, right, to find the critical points, which we did, right? We found the derivative was factored e to the power of x times cosine of x minus sine of x, right? We set it equal to 0. We found our critical points, thinking about cosine of x being the same as sine of x. So those critical points were pi over 4 and 5 pi over 4. You don't actually have to copy this down to actually get the answer here. I just want to review how we did this. All right, so I do like a number line. We're going from, let's see, we have pi over 4 is one critical point and 5 pi over 4 is another. I only care about 0 to 2 pi here, so I can't pick any negative angles. So I'm going to pick pi over 6 as a test point. Let me change colors here. I'm going to pick, for my test points, TPs, I'm going to use pi over 6 because that's between 0, right? There's a 0 here, and all the way to 2 pi. And then my test point in between pi over 4 and 5 pi over 4, I'm going to use as pi. And then my test point between 5 pi over 4 and 2 pi, I'll use as that other quadrantal down there, 3 pi over 2. So if I plug in those points in blue and think about plugging them back into this derivative, I can find the sine of my derivative over these intervals. So plugging in pi over 6, I'm going to have e to the pi over 6, which is positive. Cosine of pi over 6 is going to be positive. The sine of pi over 6 is going to be positive. And for this one, the cosine of pi over 6 is going to be, let's see, that's the square root of 3 over 2. And the sine of pi over 6 is 1/2. And the square root of 3 over 2 is bigger than 1/2. So that means this is going to end up being a positive for the sine. For pi, the cosine of pi is -1. The sine of pi is 0. So -1 minus 0 is -1. That's going to make this a negative for the sine SIGN. And then finally, 3 pi over 2. The cosine of 3 pi over 2 is actually going to be 0. If you're imagining what I'm doing in my brain, right? 3 pi over 2 is down here. Ordered pair is 0, -1. So the cosine of that is 0. The sine is -1. So you have 0 minus a -1 when you plug back in here, which is going to be positive. So then this is going to be a positive sign as well. So where is the interval increasing? So f of x is increasing on two intervals, on the interval 0 to pi over 4 and on the interval 5 pi over 4 to 2 pi. All right, the last one. Where are points of inflection? Okay, so this is taking the second derivative, all right, and finding the critical points for that second derivative, and then looking to see if we change from concave up to concave down or vice versa to figure out any points of inflection. So I'm going to take the derivative of this one up here, all right, this is my first derivative. I'm going to take that derivative using the product rule. The derivative of e to the x is e to the x times the original second function, which is cosine of x minus sine of x, plus the derivative of cosine of x is negative sine of x. The derivative of sine of x is going to be minus cosine of x, but don't forget to multiply by e to the x. Distribute. So this is e to the x cosine of x minus e to the x sine of x minus e to the x sine of x minus e to the x cosine of x. You should notice that two of these are going to be crossing out. This one here, e to the x cosine of x, and the last one, negative e to the x times cosine of the x. So that means if I put those two together, I have negative 2 e to the power of x sine of x. Setting this equal to 0, you'll notice the negative 2 doesn't have an x in front of it, so I don't really care about that. I already mentioned earlier in the question, I can never have e to the x end up being 0, so really it comes down to sine of x being equal to 0, and that happens at 0, pi, and 2 pi on this interval 0 to 2 pi. So doing my number line, I have 0, pi, and 2 pi. Get your test points. My test points I'm going to use are pi over 2 and my other quadrantal 3 pi over 2. Plugging those into my second derivative, the sine of pi over 2 is going to be 1, but then remember times that negative 2 in front is going to be a negative. So even though I didn't need it when it came time to do the critical points, when I plug it back in, that negative is super important. When I'm doing this, plugging in 3 pi over 2, the sine of 3 pi over 2 is negative 1, but times that negative in front makes it a positive. Am I changing from concave up to concave down or vice versa? I am. I'm changing from concave down to concave up at x equals pi. So x equals pi is an inflection point because f of x is changing from concave down to concave up. All right, guys, that is it for number 5. Don't forget to watch the other videos 1 through 4 if you haven't, and good luck.